So, hello everyone. Today we are going to create another C program that builds a miniature concordance or keyword in context list from a short paragraph. So, we will practice the four core of string.h utilities: the strlen, string copy, string compare, and strcat, together with careful manual scanning and dynamic memory allocation. So in this activity, we are going to let's start. So first, we have to display our so first, we have to put here our standard libraries functions, including stdio.h, std library is string, and c type. So, a- and we have also we have to define the length of the length and the size of our characters. So after that, um, since our activity is we need to read a line of text from the user, which may include letters, punctuations, and spaces. So the maximum numbers of character we're allowed to read is 500. So to do that, first we have to define a character array input array name, which is input, that can hold 501 characters. So we put here max length plus 1 because we need space. So we add 1 here because we need space for a null terminator. Next is we are going to use fgets to to safely read up the 500 characters, so including punctuations and spaces from standard input. And this point, the string might have uppercase letter and unwanted symbols. So we need to convert the entire string to lowercase for case insensitive comparison. So we did put here two lowercase and our array name input. Next step is, since we want to make the concordance case insensitive, meaning uppercase and lowercase are considered the same word. So for example, uppercase letter na all caps letters, example dog, and lowercase letter na dog are the same word. So to achieve this, we convert every letter into the input to lowercase. So to do that, we write a helper function to lowercase that uses to lower open and close parentheses from the ctype.h. And then we are going to loop through each character in the string and convert it to lowercase in place. Then next is since the goal is to isolate only words made up of letters, so a word is defined as any sequence of A to Z. Punctuations, numbers, and special characters are not part of any word. So to do that, traverse the input string character by character. And we have to skip over non-letter characters using a helper function is letter. So our next step is since the goal is to isolate only words made up of letters, a word is defined as any sequence of all caps A to Z or the lowercase A to Z letters. So punctuations, numbers, and special characters are not part of any word. So to do that, we are going to traverse the input string character by character and skip over non-letter characters using function is underscore letter open and close parentheses. So when we find a letter, we start copying it into a temporary buffet. Here, temp, we have a word here, temp, until the sequence of letters ends. Then we null terminate the word using null terminator and prepare it for storage. So our null terminator here is temp bracket equals null terminator. The next part, so now that we have a clean lowercase word, we want to track how many times it appears. So if we have seen it before, we increase its count. If it's new, we add it to our list of words. So if here. So to do that, we are going to loop through the existing word list using string compare to check if the word already exists. So if here we use the conditional statement. So if found, increment the count field for that word. If not found, so we use here reloc or relocation to expand the area of word freq structures. So first use reloc word is equals reloc word size then allocate memory for the new word using malloc. Then copy the word into the memory, then this memory using string copy and set and count to 1 and increase the size of the list. So we have here if not found words equals reloc open parenthesis, words, comma, open parenthesis, size plus 1, close parenthesis, multiply, size of, then word freak, word size. So we use here malloc, and the string length temp plus 1. String copy to copy the word into the memory, and set the count to 1 and increase the size of the list. So next is, we are going to follow the concordance format. So we need to print the words in dictionary A to Z order. So to do that, we are going to write a comparison function named compare that takes two word freak elements and uses string compare on their word field. So we have here we have here our function name compare, const void times a, const void times b, multiplied to b, and we have here two word frequency, and then compare. Then we are going to call the quick sort function from this std_library.h with our word list size and comparator. So next step is after sorting, we want to know, or no, we want to show each word followed by how many times it appeared. So each word should take up 15 characters, left aligned and followed by count. So to do that, we are going to loop through the word array and then print each word using modulo minus 15s, which align it to the left and fills and spaces the 15 characters. Then print the count next to it. So we have here the loop and print the word count, words and then count. Then since we use malloc and reloc, we must clean up the memory to avoid memory leaks. So to do that, we are going to loop through all word freak entries and call free on each word. So call free in the entire word array itself. So we have here loop from 0 to end, and then we are going to return it to 0, and we are going to try it, the code. We are going to run the code. Let's try if it will run softly. So try to put here a message. I put here, I have a dog, comma, space, and her name is Cassie, comma. She's so cute and I love her so much. So let's try if the program will count how many letters we have here. So, and here it is. So we have a word here, A, and Cassie, cute, dog, have, her, I, is, love, much, name, she, and so. So we have a word here, and the count of how many words are how many times we put the word here. So A, we have 1 count, and we have 2. Cassie, we have 1. Cute, we have 1. Dog, we have 1. Have, we have 1. Her, we have 2 letters. I, there's 2. S, there's 2 also. Love, there's 1. Much, there's 1. Name, there's 1. She, 1, and so 2. And that's all.